Good morning, students. Myself, Professor Pravin Gorantiwar. Today, I am here to deliver the lecture for the MHTCET. The topic is calculus. Now, we see here the graph, and in the first quadrant of the graph, XY coordinate system is given. Now, we know the general solution of straight line y equal to mx plus c. Here m is stand for the slope of the straight line. M is the slope. Okay. Now in this way, if we draw the curve, now to find the area under the curve in the quadrant, so we write integration limits from a to b y dx. So now slope of the curve is called a differentiation, that is known as dy by dx. So what is the first calculus? Now calculus is a study of rate of change of function and accumulation of infinite small quantities. It can be broadly divided into two branches. Now first branch is called differential calculus and second branch is called integral calculus. Now differential calculus, this concern rate of change of quantities and the slope of curve or surface in two-dimensional or multi-dimensional space. So in two-dimensional we are using the double integration, in three-dimensional we are using the triple integration. So in this way we can find the differential calculus. And second branch is the integral calculus. This involves summing infinite of small quantity. Now first of all, we must know that what is the differentiation. Differentiation is a process of finding a function that outputs the rate of change of one variable with respect to other variable. Means we find that differentiation allows us to find the rate of change. So in general we consider the example. Suppose r is the position vector of any point P, and suppose we consider the displacement, then differentiation of displacement is called the velocity and differentiation of velocity is called the acceleration. So meaning of this that differentiation of displacement, so that is velocity with respect to time, and differentiation of velocity with respect to time is called the acceleration. It allows us to find the rate of change of x with respect to y, which on the graph of y against x in a gradient of the curve. The basic differentiation rules, the sum differentiation rule are snapped to remember and use. This include constant rule, power rule, constant multiple rule, sum rule and difference rule. The constant rule, this is simple. Fx equal to 5 because 5 is a constant, is a horizontal line with the slope of 0 and thus its derivative is also a 0. So here we know first the basic rule to solve the different types of examples for the derivative. So constant rule. Now here c is considered as a constant. So d by dx of c is equal to 0. Constant multiple rule. Here any function is multiplied by constant. At that time the result is not 0. C is the constant. Then we can find the d by dx of function. So d by dx of c into fx equal to c f dash x. So f dash x is the derivative of fx. Similarly, power rule, d by dx of x raised to n equal to n into x raised to power n minus 1. Now the two rules are there, sum rule and difference rule. So two functions are given. They are either we take the sum or difference. We find the d by dx. So d by dx of fx plus gx equal to f dash x plus g dash x. Similarly, differential d by dx of fx minus gx equal to f dash x minus g dash x. Next is the product rule, d dx of fx into gx. So product of two function. So we get first function into differentiation of second plus second function into differentiation of first. Similarly, quotient rule and chain rule. So these are the basic derivative rule to find the differentiation. Now before that, we have to know the functions. Now we find that rules related to the function, but this is for the any function, either exponential function, logarithm function, trigonometrical function or inverse function. The first exponential function d by dx of e raised to x, that is called e raised to x. D by dx of a raised to x, that is a raised to x log a. Now logarithm function d by dx of log x equal to 1 by x. But here remember x greater than 0. D by dx of log of gx, that is g dash x upon gx. So in this way there are 4 logarithm functions are given. Now trigonometrical functions, 6 trigonometrical functions are there. D by dx of sin x cos x, d dx of cos x sin x minus sin x, d dx of tan x sec square x, d dx of cosec x minus cos x into cot x. Similarly, d dx of sec x and d dx of cot x. Now similarly, inverse trigonometrical functions are also given. So d by dx of sin inverse x, 1 upon square root 1 minus x square, x is not equal to plus minus 1. D dx of cos inverse x equal to minus 1 upon square root 1 minus x square, x is not equal to plus minus 1. Similarly, inverse trigonometrical functions, d by dx of inverse trigonometrical function also given. So here we will take the one of the example to solve. Now here two equations are given, x and y, but we have to find the dy by dx. Now two equations are in the form of x and theta, y and theta. So how we can find dy by dx? But we have to find dy by dx. There is no relation between two equations x and y because two separate equations are given. So x equal to a cos theta plus theta sin theta, y equal to a sin theta minus theta sin theta. Now a equal to minus tan theta, b tan theta, c cot theta, d minus cot theta. These 4 options are given and we have to choose the one of the correct options. Here, to find the relation between dy and dx, we have to use the relation of x theta and y theta. So dy dx can be written as dy by d theta upon dx by d theta. So first we find dx by d theta. So we get a theta cos theta. Similarly find dy by d theta. We get a theta sin theta. And now we can find the division, dy by dx equal to dy by d theta upon dx by d theta, that we get result tan theta. Okay. So this is the summary for your differentiation. And in next session we will solve the questions, 20 questions of this differentiation. Thank you.